Welcome back to new module 5 knowledge check. So here let's check our knowledge for this module 5. So let's start. Which use cases indicated that non-relational database might be a better solution? Horizontal scaling of massive data volume, ACID compliance for all databases transaction, data with unpredictable attributes, strong read-write concurrency, high availability, and fault tolerance. So since we are talking about relational database, so it should be horizontal scaling, and I don't think this ACID compliance for all database transactions is required, right? But data with unpredictable attributes, so this should be the answer. So I think A and C should be the answer. So you can see why A and C is the correct answer here. Which statement that compares a database service that AWS manages with database on the Amazon EC2 instance is true? You do not need to configure backup for a database on a managed database service. AWS manages DB patches for database on the managed database service. AWS manages operating system OS patches for database on EC2 instance. You do not need to configure backups for a database on the EC2 instance. So far, if I remember, so AWS manages DB patches for database on a managed database service. So we don't have to manage the DB patches. So this is the right answer here. Which examples are good use cases of Amazon relational database service? So why should we use Amazon relational database, right? So thousands of distributed concurrent writes per speed, an application that requires the database to enforce syntax rule, an application that requires complex join of data, a petabyte scale data warehouse, running a Microsoft SQL server in Amazon AWS, database for serverless architecture. The right answer here should be running, this is the advantage. We can run in Microsoft SQL server in an Amazon AWS, and also an application that requires the database to enforce syntax rule. So RDS means we need to use relational database. So we need to enforce syntax rule. And also the third option, like an application that requires complex join of data. I think this should be the answer. A small company is deciding which service to use for an enrollment service for their online training website. So they are having an online training website. Choices are like we can use MySQL on Amazon EC2, MySQL in Amazon RDS, and Amazon DynamoDB. Which combination of use cases suggests they're using Amazon RDS? So we can use MySQL on EC2, MySQL in RDS, and then Amazon Dynamo. So why should we use Amazon RDS? So data and transaction must be encrypted to protect personal information. The data is highly structured. Student course and registration data are stored in many different tables. The enrollment system must be highly available. The company doesn't want to manage database patches. So here, since we have 5 options and we need to select 3, we need to disqualify the wrong answer. So here the first wrong answer should be the enrollment system must be highly available. So this is not the right answer. And what should be the other wrong answer? So this is the wrong answer. And then data and transaction must be encrypted to protect. So I think this is the wrong answer. So the right answer here is the data is highly structured. Student course and registration data are stored in many different tables. And the last option is the company doesn't want to manage database patches. So RDS manages the database patches by itself. So I think these are the right answer. So you can read why is it. Which scenarios are good use cases for Amazon DynamoDB? So we need to select 3 here. Databases for serverless architecture, application that require ACID transaction, application that combines data from many tables, graph database to trace relationship between entities, document database for the JavaScript object notation based document, binary large object storage, blob storage. So here, since we have 6 options and we need to choose 3, let's disqualify the wrong answer. So if you want to store blob storage, we can use S3. And if you want to use graph database, I don't think this DynamoDB is a good option. So according to me, the right answer should be like it's a document database, so we can use JavaScript notation. We can use serverless because we can directly call from Lambda or something. Third option should be application that requires ACID transaction. So I said this should be the three options. That should be the answer. So we can see why this is the right answer. Question number 6. A small game company is designing an online game where thousands of players can create their own in-game objects. The current design uses MySQL database in Amazon Relational Database Service to store data for players' created objects. Which use case suggests that DynamoDB might be a better solution? So we can let's see why DynamoDB ObjectDB is better than this relational database. A set of common attributes that all player create objects have. Unpredictable attributes of player created objects. Large number of players created objects, each with different attributes. Quick search and retrieval of player created objects. High amount of read activity on players created object. Unpredictable attributes for player created objects, and large number of player created objects, each with different attributes. Because we use Dynamo object database because of the unpredictable attributes. It can be many attributes, right? So I think B and C should be the right answer. Because player create their own object, the object attributes are unpredictable. So this is the best answer. Question number 7. Which technique should you use to secure an Amazon Relational Database Service, RDS? AWS identify and access management policies to define access at the table, row, and column level. Security groups to control network access to individual instances. An Amazon Virtual Private Cloud Amazon VPC gateway endpoint to prevent traffic from traversing the internet. A virtual private gateway to filter traffic from restricted network. A virtual private cloud to provide instance isolation and firewall protection. Encryption to protect sensitive data. So using RDS we can encrypt encryption. We can get encryption to protect sensitive data. A virtual private network to provide instance isolation and firewall protection, and also we can, I think, security group to control network access in individual instances. I think this should be the right answers. Which techniques should you use to secure the Amazon DynamoDB? An Amazon Virtual Private Cloud Amazon VPC gateway endpoint to prevent traffic from traversing the internet. AWS identity and access management policies to define access at the table, item, or attribute level. Security groups to control network access to individual instances. A virtual private cloud to provide instance isolation and firewall protection. A virtual private gateway to filter traffic from restricted networks. Encryption to protect sensitive data. So what should be the answer here? So the first option here, what I could see is a virtual private gateway to filter traffic from restricted network. So this way we are securing the Amazon DynamoDB. And encryption to protect sensitive data. So this way we can secure Amazon DynamoDB. And also AWS identity and access management policies to define access at the table, item, and attribute level. So this way we can secure the Amazon DynamoDB. So it says incorrect because DynamoDB is serverless. It does not have instances that deploy in a VPC and use security group. So this is incorrect. So it's okay. Let's continue. A company wants to migrate their own premises Oracle database to Amazon Aurora MySQL. Which process describes high-level steps? Use AWS Database Migration Service to migrate data from Oracle database to Amazon Aurora MySQL. Use AWS Database Migration Service to migrate the data, and then use AWS Schema Conversion Tool to convert the schema. Use AWS Schema Conversion Tool to convert the schema, and then use AWS Database Migration Service to migrate the data. Use AWS schema conversion tool to synchronously convert the schema and migrate the data. So we want to migrate their on-premise Oracle database to Amazon Aurora MySQL. So I think they can use AWS schema conversion tool to convert the schema, and then they can use AWS database migration service to migrate the data. So yeah, so this is the correct answer. Question number 10. You must perform a heterogeneous migration from your on-premise facility to a database in a virtual private cloud. You will use AWS Noble Edge and AWS Data Migration Service. At which points do you use AWS schema conversion tool? At the start, to extract data from source database into the Snowball Edge before shipping the device. After extracting the data from source database by using AWS DMS, but before shipping the Snowball Edge. After the data is in the VPC, but before using AWS DMS to load the data into the target database. After using AWS DMS to load the data into the target database in the VPC. So I think the correct answer here should be like, we can use it in the start and to extract the data from the source database. So we will extract the database data from the database before, like, and then we can ship it to the device. So I think the first option is the correct answer. So we can see why that is the correct answer, because AWS SCT connects to a database engine. You should run it locally. So this is the correct answer. Okay, so this way we were able to answer 9 questions out of 10 and we scored 90%. So I think, so if you know the answer for the wrong question, please add it in the comment section so that the other will be finding it helpful. So till then, see you in another module again.